Welcome to qnawire.
Chapter 16, problem 120. The question's asking at 50 degrees Celsius, the ion product constant for H2O has the value of a Kw of 5.48 times 10 to the negative 14th. The question's asking what is the pH of pure water at 50 degrees Celsius, and then based on the chart change in Kw with temperature, predict whether the delta H is positive, negative, or zero for the autoionization reaction of water. So first, for part A, we are trying to find the concentration for our HI, and we know that Kw is equal to your Ka times your Kb, which is also equal to your H ion concentration times your OH minus. And also, whenever we're dealing with water, they're equal to the same thing. So they're just going to be your Kw is equal to x squared. So they're giving us a Kw. It's not just our general Kw we use because we're at a different temperature. And it changes for water. So we're at 5.48 times 10 to the negative 14th. And it's equal to x squared. So to find x, we just have to take the square root of both sides, and x is just equal to 2.34 times 10 to the negative 7. And now we just need to find our pH. So our pH is equal to our negative log of our H ion concentration. And like we said earlier, x is our H ion concentration. So the negative log of our 2.34 times 10 to the negative 7. When you plug that into your calculator, you get a pH of 6.63. So now, since we have the pH, we can answer the next question. And it says we are trying to predict whether the delta H is going to be positive, negative, or zero. So to be able to answer this question, we had to put our equilibrium constant in relation to the temperature. And to do this, we're going to use the Van Houten equation. And the Van Houten equation is the ln of your Kw over dt, which is equal to your delta H over RT squared. So what it's really talking about in this equation is whenever you take the natural log of your Kw, it's going to change in ratio to your delta H. So to know whether your delta H is positive or negative, the sign of the left hand of the equation is checked. So the number, we are going to be positive, and then the K value increases from there. So we go from original Kw at 25 degrees Celsius is 1 times 10 to the negative 14th. Our Kw that we're working with is 5.8. So since our Kw is increasing from 1 to 5.8 times 10 to the 14th, we know that it's going to be positive over here, and then therefore that our delta H is going to be positive as well because it's going to increase in the same way because of the ratio. Whatever happens to the top is going to happen to over here as well. So our delta H will be positive.